Troy Clark, Clark Machinery Sales, Hunt Valley, Maryland, on the Beltway.
I'm a Beltway, baby.
Troy, we look at CNC equipment, and you buy and sell a lot of CNC equipment. And as an appraiser, I'm always trying to determine if there's some magical age or amount of hours where that depreciation curve in value just drops. Is there a magic age where that equipment starts to become less valuable or really falls off in steeper chunks year over year?
I think so. I don't think that there is a technical appraisal number, but there's definitely a psychological number in the minds of a buyer and in the minds of us, because we have to figure out what the buyer is going to perceive when they look at something. 5 years is a big deal, but 10 years is the magical drop off.
10 years.
The number of hours, 10,000 hours. I'm sure you'd agree. 10,000 hours and under, 10 years and younger, cutting aluminum.
Cutting aluminum. It's the old lady that drove her car to church on Sunday.
That's right.
Interesting. 10 years, 10,000 hours. I haven't heard the 10,000 hours. Is that driven just because of the psychological roundness of it? Or maybe is there something that has to do with the changes in control over a 10-year window?
No, because listen, guys can have a 5-year-old machine and have 10,000 hours, right? So what's a single shift? 2,000 hours. Right. So if it's running 3 shifts, you're 6,000 hours. So you can put on 10,000 within 2 years.
Yeah.
Really. It's, okay, let's use another metaphor. So let's look at tires on a car. They're good for 50,000 miles, let's say, right? You got a Michelin tire. They're rated for 50,000. And you go, well, again, that grandmother driving to church, she's going to hit 50,000 in maybe 8 years. Okay. So if I know that the tires are 2 years old, well, they've only got 10,000 miles or 15,000 miles. They're fine. Same thing with a machine. So if it's 10 years old and they've used it half a shift, that's 10,000 hours. Okay. So because people are thinking, I know that Haas spindle, we do a lot with Haas. Now, a Mori spindle, they may be able to handle more than 10,000 hours. But most everybody thinks Haas spindle, 10,000 hours. I'm going to have to dump another $6,000 into it and another $15,000 to $2,000 for a Haas Tech. That spindle's shot. So it's over 10,000. I need to make an offer lower than $7,000 off, because I know I'm going to be putting, even if it sounds gorgeous, I don't care if they were cutting butter. I'm going to have to put a new spindle. So I think that there's just road miles, that idea of all the mechanics get tired after a certain number of miles or hours.
And that magic number is 10 or 10 or 10 and 10?
I think so.
How do you measure the efficacy of control changes when you evaluate the value of a used piece of equipment?
From talking to some of my friends that specialize in other areas. So I have friends that specialize in electric discharge machines, okay, or lasers. They say that things antiquate far more quickly than I would perceive in metalworking machinery like lathes, machining centers, okay? And then, of course, obviously you get into benders and brakes, and I don't think they antiquate as quickly. That's my estimate. So you can operate a machine perfectly fine with a Fanuc OT, and they were putting Fanuc O's, in the 1990s? Yeah, so they're fine. I know that the nomenclature changed a little bit, but a 2-axis is 2-axis, and maybe you can get faster feeds and speeds, but you're only pushing metal so quickly at 6,000 RPM on a lathe, and I don't think it's as big a deal unless you're needing to extract 5-axis work from a control. Then do you have the read ahead, the look ahead ability? Because sure, a 5-axis control is vastly different now than it was 5-10 years ago.
Yeah, good point. Do you think that we're reaching the, how Moore's law kind of fizzled out? Do you think that we're reaching the limits of our ability to make more complex control? I mean, you've only got so many axes of movement, right? I mean, how much further can we take this in control improvements?
Great question. I think sometimes it's like Apple. I mean, they're cranking out a new OS because they need to sell it. Here's the new phone, but the phone isn't as huge of a leap as it was, let's say, 3 years ago. It's just not that dynamic, but you're going to pay $700 for it. I think now you're getting more interconnected controls, right? So where it's sending communications by Wi-Fi so that you can manage it remotely.
On your cell phone, right?
Yeah. Well, look, you're seeing people walking around with iPads around the shop, and they know each machine, and it's reporting back where it is. I think those things are huge. That's going to be leap year stuff. Like, that's going to push you forward.
So what you're actually describing isn't so much a singular machine control, but it's more the integration in full factory automation and control and monitoring in a production control sense. Those are the improvements, the integrations.
I agree. We sell all machines, but because certain machines bore more fruit more quickly and people were picking up the phones, we went with Haas. Haas was sort of our base. So let me just give you an example. Haas back in 1988 or whatever, in 1989, when they started making machines. Well, the big shift, those were all the same, maybe more horsepower, but 1997 was the big cutoff. What happened in 97? Vector drive. Whoa! So vector drive, what's a vector drive? It gives a feedback loop to the control. It goes, hey, we hit resistance. You need to jack up the horsepower just for a few seconds. And so it can keep those speeds and feeds. So 1997 is a plateau. The next plateau for Haas, well, what were the other huge developments? Nothing. Like, they were all neat things that happened, but that's the biggest one. That was the single greatest inhibitor of pricing, okay? Well, then 2008 came along and they shifted in their CNC module, and that is a plateau. So now that has value below. But what's the big difference between the 2007 and the 2008? Really nothing. Maybe a few extra G codes, M codes, whatever, but really as far as the function, nothing. But along the way, they and other companies said, you know what? We can do faster feeds and speeds, faster processing. Again, I really think it's all about the read ahead. It's about how quickly can the computer do the calculations to ramp up to that corner and then slow down so they can do the corner and ramp up as quickly as possible. I think those type of things are the big deal with the controls. That's what I hear people talking about. Or like Kitamura. Oh, I need to be able to program out to the third, the fourth, the fifth decimal point. Well, so as Kitamura's got newer and newer, guys wouldn't buy the F series. They wanted the G series. So why? Well, because they could program to a decimal point further out.
And is that tolerance or is that speed?
That's a tolerance thing, so they can be even tighter. But so I think speeds and feeds, tolerance, but our controls. I mean, I don't know what's the future of a control that it's out in the air. That they can just air touch, and I don't know really what advances you're going to make. But look, machines have come so far where now people don't need jig bores, right? That's not as critical. You've seen those prices plummet, because the machines can be so highly tuned that you don't need that jig precision.
Very cool. Great insights. Troy Clark Machinery Sales, Hunt Valley, Maryland. Thanks for your time this morning.
Thank you, David.